Zombie Apocalypse.
Okay, so today's topic is collapse mechanism. So this time, we will try to apply all the concept that we have discussed, no? Considering a single span with single concentrated, with two concentrated loads, and a uniformly distributed, or maybe a combination of both, no? But this time, let us try to adjoin all of those spans and analyze a continuous beam. So how do we set the analysis? So let's get ready to be neurarized. Okay, so suppose that we have this load. Now, if you will notice, we have P1, P2, and P3, and a load W. And on the right is a fixed support, okay, at point A. And the rest at B, C, and D are all hinged. So we have a continuous span, no? Because we define as a continuous span if there are more than one span, ano? And then it is already identified with the values for dead load and live load. So meaning, we need to analyze this based on ultimate state design and then turn back it to nominal state, no? So just like what we have done numerously before this video lecture for under collapse mechanism. And our main objective is to calculate the governing plastic moment of the given continuous span. We will try to compare it also do sa makukompute natin plastic moment, do sa mga moments siya if we are going to solve this using theory of structures. Okay, first things first. So the usual routine based on the load combinations, ano, we are going to calculate the ultimate load value based on P1, P2, P3, and W given specifications. So if you recall, if there is dead load and live load, we need to use the first two load combinations, the 1.4 times the dead load alone, or simply the 40% magnification of the dead load, and the load combination number 2 would be 20% magnification for dead and 60% magnification for live load. That's why for P sub 1, you are going to calculate P sub 1 sub U by these calculations, no, as shown. And then eventually we will have 197.2 kilonewton. Again, how do we select this? We just compare these two, and then the largest will prevail, which is 197.2. And then that is a value that you are going to plug in as a value P1 under ultimate. Note that I have a subscript of U to denote that this is under ultimate state. And then later, it is the option of the one who is solving if he is in desire of converting it immediately into nominal by dividing it by 0.9. So it's up to the one who will solve for this. But for the meantime, for my approach, I will leave it as an ultimate, and then later, on my calculation of plastic moment, I will derive it based on the definition of nominal by dividing it by 0.9. And for P sub 2, we are going to have 292.4. For P sub 3, we are going to have 107.8. And for W sub U, which is the distributed load, which is 29.12 kilonewton per meter. So those are the values that we are going to plug in to analyze the next setup. Okay, ano? Nakita nyo na nilagay na natin yung mga corresponding values na nakalculate natin kanina. This will now materialize the calculation for the plastic moment. Ngayon, what is the rule in analyzing a continuous beam? Now, just like in a particular beam, let's say, we go back to theory of structures. Let's say, we have this, let's say, a fixed support. Okay? Let's say we have this kind of setup. Okay? Or even more than that, more than support like that. Okay? Okay. Now, if you recall, there's what we call the interlocking moments, no? The basic idea of a continuous span, okay? Now, it means that if there is an interlocking moments, now this is already discussed during theory of structures. There is a video explanation for me explaining these interlocking moments all about by having my playlist, no? Can you check for a while yung aking playlist? So I will assume that you are already aware. If not, please visit my playlist under theory of structures, and then select any method discussing continuous beam. It's either three-moment equation, slope deflection method, method of consistent formation, and moment distribution. Now, as we go back, we have this what we call interlocking moment that, of course, we are aware that if we have hinge and we have rollers in the interior side, the moment is zero. But applying the third law of Newton, let's say this is m sub 1 and m sub 2, then m sub 2 no, can be said as to be zero. However, the sum of moments at 2 is just only zero. Therefore, there are two forces or there are two moments, okay, that rotates but of opposite direction. Okay, but of course, it is under equal magnitude. That is the third law of Newton all about. So therefore, those are what we call the interlocking moment. Question: what would be the effect of the interlocking moment if this is now under collapse mechanism? Now, you are going to treat that as a portion of a hinge, no? Kasi pagka nagkaroon ka na interlocking, meaning may resistance ka sa rotation. So, it means that it is an immediate resistance to rotation, no? Kaya di ba usually we have transition of the bending moments. Let's say from negative it becomes positive like this. Okay, no? Negative bending, positive, negative, positive, negative, no? Positive and negative. So just like in of course in a simply in a supported span na walang fix. Okay? So, ganun din naman yan, ano? Yung nga, nasa magkabilang dulo, malaki yung pagka-bend niya. And then finally, dito, yan. Okay? That's the core concept, no? So, positive, negative, positive, negative, positive. So, it is, ano, nagpapalit-palit, ano? So, yan yung konsepto ng interlocking moment. So, therefore, on the portion of the interlocking moment, that's what we are going to analyze. So therefore, there is a resistance, no, do sa pag-rotate. That's the definition. Yes, it is allowed to rotate, but there is a resistance. Yan yung pinagkaiba ngayon sa single span. Na alam natin kapag hinge roller ang magkabilang dulo or isa sa magkabilang dulo, the rotation is free the point is free to rotate, right? The rotation is not resisted. So therefore, there's a quadrantal value na malaki-laki yan. Pero in a continuous span, there's what we call interlocking moment. Therefore, the moment is already suggesting as an interlocking state that there is a resistance doon sa ating point of the support interior. We're talking about interior. So therefore, if that's the case, then there should be also what we call interlocking moment under plastic condition. Or we can call it the plastic interlocking moment. Okay? Now, so therefore, what do we understand by this now? So there will be plastic hinges immediately found dun sa ating mga interior supports unless it is an internal hinge, magkaiba yon. So meaning point B, point C is an automatic plastic hinge, no? While on D, okay, is different because D is the exterior support, meaning there is no resistance to the rotation, so therefore D is treated as real hinge. Of course, it is obvious that at point A is treated as a plastic hinge because it is fixed. So, how do we deal with this, no? Ang pag-calculate ng plastic moment on a continuous beam is you are to detach all the spans. So, you're going to have span AB, you're going to have span BC, okay? You're going to have also span CD. So, therefore, you are to detach them based on the points of attachment to the support and then analyze it individually. Now, you will observe that there are 3 spans here. So, therefore, you are to analyze 3 of them. So, let's start with AB. So, in AB, notice that this is the load, no? And then, of course, as we recall the principles discussed in the past video lectures, that if you have a concentrated load that is under single application, of course, sa ilalim ng load natin, siya mag-deflect for a plastic condition, okay? So, therefore, applying the principles we have discussed before this video lecture, then this is the right time to demonstrate those concepts, no? So, therefore, this will be the illustration of the collapse mechanism diagram as you recall it, okay? And then, we have plastic hinges at A. We are sure of this because this is fixed support, no? This is fixed, yan. And then on the point of hinging, which is below the load, of course, is another plastic hinge, okay? And the B, of course, it seems that, of course, we know that B is a hinge support. However, we know that support B, no, has an interlocking moment. So therefore, it also has plastic interlocking moment. So therefore, if there is a plastic interlocking moment, it resists rotation. So therefore, we can say that at point B is also a plastic hinge. Okay? So we are sure that at point B is not a real hinge. Why? Because there is a resistance of rotation for under plastic condition. Okay? Therefore, all of the points are considered plastic hinges. And then, as we proceed with the small angle theorem that we already know by looking on the figure, and then finally getting the plastic deviatoric slope, as we already know, the sum of the slopes of both supports, that is forming the triangle or the shape of triangle. And then finally, using the uh, energy is equal to energy out situation using, of course, the direct principle of virtual work method. Now, notice that I have divided the 197.2 kilonewton by a zero point 0.9 since we are aware that the energy is equal to energy out situation understands and considers nominal state. So, Pn times delta equals the plastic moment multiplied by the sigma or the sum of all plastic angles. Okay? So, of course, Pn is just only P sub u over phi, where the phi is zero point 0.9 for flexure under steel design. And then finally, we understand that all of the states of the angle, the sum of angle for theta A, of course, this is delta theta P, and a representation of theta B. Okay? So we know that theta B is 3.2 theta A, and then you just plug it there. Then finally, we'll get a 208.6772 kilonewton meter. Now, what's the objective of computing the individual states of each span? We are to get the maximum possible plastic moment that we can get from the system, and that will be our declared governing plastic moment. Now, for the meantime, we know that AB has a plastic moment tendency to have hinging under the value of 208.6772 kilonewton meter. Now, we are going to compare this, no, itong value na to, doon sa sagot ng BC at saka ng CD. So, for the meantime, this is the first candidate for the governing plastic moment. Now, we proceed on segment BC. Now, notice that under BC is a composition, okay, of two concentrated loads. Okay, we have 292.4 and 107.3. Okay, so by representation, we need to understand in one of my video lectures, I have discussed already that under this situation, there can be cases of hinging. And these are the following. Now, note that before we start analyzing span BC, now I will try to erase that first, okay? Notice that at B and at C is the interior supports, and both of them has interlocking moments, as we call it, no? Do sa ating calculations in theory of structures, and also considered by authors of the references for theory of structure, so they call it also interlocking moments. So if again in the presence of interlocking moment is a presence of plastic hinges, because if there is a interlocking moment, then in collapse mechanism there should be also a plastic interlocking moment that we can also calculate and provide. Now, so therefore, as we calculate this, no, as we proceed with segment BC, now the first case, if the 292.4 kilonewton governs from the statement, then you will see under the first case, and then doing the analogy for energy is equal to energy out, and as well as the calculation for the small angle theorem, then you will find a value of 479.5728. Note that all of the points B, C, and E, now I designate point E below the load 292.4 and letter F, no, do sa 107.8 kilonewton, so that it would be nice for us to calculate in that way para may designation of the letters, para di tayo mahirapan to designate it as we calculate. So delta E represents the load deflection caused by 292.4, and delta F is the same for 107.8 kilonewton. So therefore, you will have this 479.5728. Likewise, now if that is the case, likewise, on what if the load 107.8 kilonewton governs, then therefore the deflection will be coming from the plastic hinge at load 107.8. Okay, that will be the governing state of the hinging, and then doing the small angle theorem analysis, correlation, and as well as the energy is equal to energy out, then we will have 263.6958. And of course, completing the analogy, what if both loads, no? What happens here is what if both loads will execute equal deflection, or both of the points will consider flat leveled hinging. That's why we have on E and F, it is horizontal in nature. Then we will have this correlation, already discussed in the past video lecture on how to do it. And then finally, we'll have 322.8402 kilonewton meter. Also, what if, no? What if the 107.8 kilonewton prevails for the plastic hinging? However, the 292.4 kilonewton does not allow hinging. Because this may happen. There are potential 5 cases at least to analyze. So therefore, that's the case, no? The 292.4 kilonewton load relaxes under hinging, and the 107.8, no, considers hinging. Okay? So therefore, by analysis, you will get this small angle theorem and then the correlation of the energy in and the energy out. Then you will find 71.8667 kilonewton meter. And also doing the same, on the other side, what if the 292 kilonewton, 0.4, kilonewton value produces hinging, and the 107.8 kilonewton relaxes for hinging? Then this would be the case, no? Already discussed in the past video lecture. Now, just in case you missed the, if you want to review again the core concepts regarding this, please visit my playlist under the same topic, no? Steel design, structural steel design. Then kindly search for collapse mechanism of a single span with 2 concentrated loads. Okay? And then finally, as we continue, then doing the same, and then we will have a 311.81888 kilonewton meter. And then for span BC, again, the selection process to get the largest value, and then we will have 479.5728 kilonewton meter to represent span BC. Because under these 5 cases, the first case, so tawagin natin ito yung case 1, ito yung case 2, no? Ito yung case 3. Okay, case 3. Sabi natin ito yung case 4, and this is the case 5. Okay? C5 na lang. Okay. So, case 1 prevails, meaning pinakamalaking plastic load na bibigay sa span BC lang alone is the first load, that the 292.4 kilonewton governs, and then the 107.8 follows the governing pattern of the hinging. So, this will be the representation of span BC, but we are not yet done because we are going to analyze also CD. Okay. So, kung makikita nyo po sa left screen, left side of the screen, no, nilalagay ko doon sa kaliwa para may tayo, ma-recall natin yung mga selection natin. Yung mga, for the selection, I mean. So, this MP again is best for AB, while the 479.5728 represents BC. But how about for CD? Okay, no, already discussed before that we already derived that the point D is taken as real hinge, no? Kasi wala siya ng adjacent span at wala siyang interlocking moment. Again, in the presence of interlocking moment, as you know it on theory of structures, no? Then, therefore, there should be plastic hinge. We are aware that on point D, no, it does not have an interlocking moment based on theory of structures principle. So, therefore, we can say that at point D is a real hinge. And the rest, like at the point of hinging, and of course at the point of interior support at C, creates plastic hinges. Okay? Now, we already derived that the distance of the plastic hinge nearest to the hinge or roller support that is under real hinge is taken as 0.4142L, or if you want, you can use the square root of 2 minus 1 times the span, no? Already derived before. And then the span is 5 meters as given on span CD. And then finally, we can substitute that. Now what we do, I use the 0.4142L correlation, then I have calculated as 2.071 meters to replace the distance, and of course we will be getting 2.929 meters on the remaining distance for correlation. And then finally performing the small angle theorem and the energy is equal to energy out state. Then finally there is a value of 69.3915 kilonewton meters. So already discussed with you, but nagkaroon ng 1 up dyan? Because the load is being translated regardless if that is symmetrical or non-symmetrical. You always take the half of the load kasi already explained before, kahit ilagay natin pa sa ganito yan, let's say ito, dulo-dulo, yung reaction, pero hindi yung load, hindi dulo-dulo, yung treatment pa rin kasi ng load mo is kinukuha yung tigka kalahati. Okay? Wn, of course, over 2 yan, ano? Okay. Wn over 2, then Wn over 2. Of course, times let's say the distance of B, no? B and B. Kasi there's also, of course, there's always an equivalent Wn times B. At kinukuha natin yung kalahati, isang kalahati lang. Kasi nagpo-produce ng deflection property as plastic is concerned. Now, so this will represent the answer for span CD. Okay, so by representation, ito no, yung nakita nating drawing dito sa baba ng span natin. So we will notice that this is the image of the plastic is on AB. And kanina nakita natin on BC, nag-govern yung load na 292.4. And of course, this one is for the identify natin kanina. Now, so therefore, this is what you call the plastic moment diagram analysis, okay, or collapse mechanism diagram, na pag binuo-buo natin, yan yung continuous span collapse kung tinatawag. Okay? Ngayon, as we have MP of 208.6772 kilonewton meter for span AB, and for 79.5728 for BC, and MP of 69.3915 for CD, then the largest would prevail. And then we will get 479.5728 kilonewton meter for that side. Now let us correlate this using theory of structure. So, tingnan natin ano ba yung diagram illustration. Now, ito ay kahit ano method na yung gawin natin. Okay? Now, by this, I have chosen to use 3-moment equation for simplicity. Then, if you miss the topic, then kindly revisit yung aking theory of structures playlist under the topic of slope deflection method, 3-moment equation, moment distribution method, and method of consistent deformation. So that you can relate yourself, lalo na sa 3-moment equation, ba't ako nag-arrive sa tatlong equation na yan. Now, having these 3 equation that I have performed here, now for me to identify the interlocking moments of the span using theory of structures, then we will have the following data. Okay, so using 3 equations, 3 unknown, or you can use whatever method that you can use for us to identify the value of MA, MB, and MC for that particular equation. Then we will have these following values. So notice that MA, MB, and MC are all negative moments. So meaning the bending is negatively. So therefore, that is a proof already that there will be negative bending. And a purpose of showing that there is a transition from positive to negative, then it is an evidence that there is what we call an interlocking interface. So, of course, if there's interlocking interface, there is a resistance of rotation. Okay? Lalo na doon sa fixed support. And then, if you want to understand the way I do this, no, andun yan sa aking playlist on theory of structures, no. Pinawanan ko yan na kompleto. Again, on those particular topics like moment equation, slope deflection method, method of consistent deformation, and moment distribution method. So, kindly visit na lang yung ating playlist. Now, what do we have here is we have obtained the net moments taken from the interlocking moments as we have produced here on B and C and A, okay? No, yan yung mga evidences natin. And then, finally, as we get the net moment reactions, okay, pag negative, pababa, at positive, pataas, and then simple span reaction, then the reaction at A is 13.4453, The reaction at B, 346.8064 kilonewton, and reaction at C is 387.4953 kilonewton that goes up. Yun nga lang, sa reaction at D, it is 4.747 kilonewton that goes down. Ngayon, as I draw the shear and moment diagram, then our main interest is the moment diagram, and then here are the two figures for your validation, of course. Then, what do we need here is we are going to compare the moment diagram based on elastic theory versus the collapse moment diagram. Okay, so ngayon, based on the moment diagram na under ultimate, don't forget this is under ultimate. So why it is under ultimate? Because our loads no taken from the calculation are all factored. So meaning it's under ultimate. Ngayon, if you want to get the nominal, so divide nyo lang po sila sa 0.9. Okay, just divide it 0.9 here, 0.9 there, and all the loads, okay, to get the nominal value. Pero, there's no need for us to get that kasi our main objective here is to compare, and of course we need to identify kung saan magsisimula ang hinging then followed by the next points. Okay? Now, how do we identify that? We need to identify first kung saan magkakaroon ng hinges. Okay? Let's count. On point A, on the load 197.2, on point B, at kayo na nag-govern yung at point 4, yung ating 292.4, at yung 107.8, sumama lang naman dun, ano? So, therefore, hindi na natin siya isasama as hinging kasi hindi naman sila nagpantay. Unless pag nagpantay, doon siya nag-govern, then that will be the fifth hinge. Okay? But here, what happens is, nakisama siya sa hinging nung mas malaking load based on the proof. Okay? And the fifth on C, and on the 6 naman sa H, which is kanina na-locate natin ito as 2.071 meter, ano? But if you notice, in this diagram, wala tayong value. Okay? So, let us calculate ano kayong value na yan. Now, if you recall, may load reaction tayo nakuha under elastic theory as 4.747 kilonewton that goes down. No? And then this is 29.12, and the distance is 2.071. So our main objective is to get that moment, and then the moment can be calculated as, if you notice, it is negative bending kasi nasa right hand cut ka. So lahat na clockwise, negative ngayon. So negative 4.747 multiplied by 2.071, which is yung 2.071, no, ito yung ano, yung 0.4142 of L, if you recall. This is already derived in my past video lecture. Now to continue, minus 29.12 over 2 times 2.071 squared. So we will get by calculation as 72.2795. So ito yung qualifying value natin. Okay. Ngayon, tingnan natin saan sa magsisimula. Of course, at the point of the maximum plastic moment will start. So, dito po mag-start, yung bibilugan natin sa ilalim ng load na 292.4. And then the next possible, ang reference nyo po yung moment diagram, ano? Ito kasi yung pinakamalaki. So, sumunod si 389, which is located on point B. Okay? And then followed by the 387. Okay? So, at point C. And then, the next value, natitira na lang ito, no, yung apat. So, which is we have the 86.5623 as ultimate, which is located on, actually, we cannot select this. Why? Kasi itong 86.5623 is taken from the load below the 107.8, which is, in fact, wala tayong hinging na nakikita dito. Okay? So, therefore, this load cannot be a selection, okay, as instructed. Now, to continue, so, ang susunod dito, yung 72.2795, which is on this point, no, fourth point. Okay? And then, finally, the 69.8192, nandito, sa ilalim ng 197.2 kilonewton, which is the fifth point, and finally, the last point, no, which is that negative 37.7425, is the sixth point. Tandaan po natin that there is only 6 points of hinging na under plastic condition. So, the number of the plastic hinges represents the number also of the order kung ano-ano yung mga magtutupian in our term. So therefore, this is how we interpret the correlation between the moment diagram against the collapse mechanism diagram, the CMD as we call it before. So, ang order of hinging is illustrated already under this drawing. Okay? Yung mga number na may bilog. While yung kulay violet ng mga numbers, sila yung mga identify nating plastic hinges. And don't forget, the points of the plastic hinges, okay, doon tayo din maghahanap ng order or chronological order of plastic hinging. And that's how we deal with the collapse mechanism of a continuous beam. Kahit both fixed pa yung magkabilang dulo or kahit walang fixed support sa magkabilang dulo, tandaan lang po natin, kapag nasa magkabilang dulo, that is ang kanyang hinge support, it is already identified as real hinge. So, kumbaga, kahit ganito siya, kasi kahit ilang pa support yan, okay, immediately, the two opposite supports, kapag hinge naman o roller support, both of them are real hinge kasi it allows rotation. Okay? So, yan po yun. And the rest are plastic hinges. Okay? At plus, the loads na i-consider mo, additional plastic hinges. So, that's how we identify the numbers of the plastic hinges and the real hinges. You know? So our next topic would be the deep understanding of the nominal moment equals or less than sa plastic moment. Kanina, at yung mga past video lectures natin, it is just only for the nominal moment because it is taken from the loads. Okay? Na tandaan natin na may sarili siyang condition for nominal moment and the plastic moment. Okay? Ngayon, we will discover the true plastic moment na magagaling naman sa cross-sectional area. So, dito na natin makikita paano na hinahandle ng shape of the steel sections ang pagkarga as for hinging effect ng loads natin na inilalagay sa steel beam. Okay? So, that is our next topic. So, dito madidiscover natin yung relation ng nominal moment, plastic moment, and this time, the yield moment. Tatlo na yan, ano? But again, all of this will be taken from the cross-sectional area. Okay? So, again, as our tradition goes, you have been neurorized and see you in our next video lecture.